This video is finding confidence interval for a difference between two
A
means.
very good day. Today we are going to learn the confidence interval for difference between two means. The learning outcomes is finding the confidence interval for difference between two population mean where the both case sample size are greater than 30 or the population variance are known. And in this case, since the sample size are greater than 90, we use a Z distribution. And the confidence interval for difference between two means will be, so you got the difference between two mean. Let's say the mean for population 1 is a bar x1, mean for population 2 is a bar x2. So the difference between two mean will be bar x1 minus bar x2. The confidence interval, the left confidence limit will be minus Z alpha over 2, and then multiply with the square root of the variance divided by number of sample 1 plus the variance of sample 2 divided by number of sample 2. The upper confidence limit, the minus here become positive. So for this video, we'll focus on the first case first. First case, where both sample size are greater than equal to 30 or the standard deviation are known. Then we use the Z distributions. So the example 6, because continuous for is continuous from the previous lecture, confidence interval for single mean. We stop at example 5 now. So this is example 6. And then the question is, do people who eat, give the laser pointer, do people who eat high fiber cereal for breakfast consume on average fewer calories for lunch than people who do not eat high fiber cereal for breakfast? So means the mean for population 1 is those who have high fiber cereals. So will they have a lower calorie for the lunch compared to the second population who takes who do not eat high fiber cereals. And we have a sample of 150 people was randomly drawn. Each person was identified as a consumer or not consumer of high fiber cereal. For each person, the number of calories consumed at lunch was recorded. So we got totals, consumer and non-consumer total is 150. So the data just shows some of it only. And whereas N1 is those who consume high fiber during the breakfast, number of sample is 43. N2 are those who didn't consume high fiber during breakfast. So number of sample is 107. The mean for sample 1 604.02, mean for sample 2 633.239. And then since the number of samples are greater than 30 and also so we use a Z distribution, and where the S1 squared given is 4103 answer. Population, the variance for second population are 10,670. So the claim to be tested, we use a 95% confidence interval, mean the alpha is 5% or 0.05, and the claim to be tested is the mean caloric intake of consumer mu1 is less than that of non-consumers mu2. Means population 1 is those who take high fiber, and then population 2 are those did not take high fiber. And then our claim is those who take high fiber will have less calorie. So means the mu1 less than mu2. Mu1 less than mu2. Or mean mu is a population mean of sample 1 less than sample 2, or mean this is a sample means will be bar x1 minus bar x2 plus minus Z alpha over 2 times square root of the population 1's, okay, variance of population 1 divided by n1 plus variance of population 2 divided by n2. So we plug in all the bar x1, bar x2. Okay, how we get z alpha over 2. Okay, 95 confidence interval, alpha is 0.05, alpha over 2 is 0.025. 0.025. Hold on, sir. Need to ensure you all the full statistical table. Okay, using the table 4, the normal distributions, 95 confidence interval, alpha will be 0.05, alpha over 2 is 0.025. The value for z, okay, z alpha, where the alpha 0.025 will be 1.96. 1.96 here. 1.96. Okay, and then can we why like this, huh? Okay. We'll put in this thing into the calculator. I will present the bar x1 as a alpha A, bar x2 as a B. So first of all, I put the minus. Okay, the z alpha over 2 will be my C. Okay, C, and then multiply square root of the variance for population 1. Okay, variance, let's say you want to use variance ABC, let's say this will be D. Okay, and then let's say the sample ones, let's say will be E. And then the variance for population 2, F. Okay, sample for population 2, let's say A, B, C, D, E, F, have used it. You can use X, Y, M. Let's say I use M. Okay, it's up to you to define your own variable. Then I calculate. I refer back to the slide here. Then I will calculate. A is actually mean for population 1, 604.02. B is a mean for population 2, 633.239. C is a variance for population, which is 4103. D is my sample 1, 43. E is a variance for population 2, 10670. Okay, F is a sample for population 2, 107. So, hold on. See, where's the formula? Oh, C. Okay, A value correct, B correct. Okay, C wrong. C is a Z alpha over 2 as what we showed just now. Okay, alpha over 2 0.025, 1.96. Sorry, C value is wrong, 1.96. All the value run. D is actually the variance for population 1, 4103. E is a sample size for population 143. F is a variance for population 610670. Okay, M is a sample size for population 2. So you get here the formula here minus. So the lower confidence limit is negative 56.5986. To get the upper confidence limit, we edit the formula, the minus become plus. So get negative 1.8394. Negative 1.8394. Hence, okay, for the 95% confident interval, okay, the confident interval between, okay, for difference between these two mean will be negative 56.59 to negative 1.83. So we are 95 confident that the interval negative 56.59 to negative 1.83, okay, you see that interval is actually at the negative side. So contain the true, okay, but unknown difference, okay, for the difference between two population mean mu1 minus mu2. Mu1 minus mu2. Okay, since the interval is entirely negative, that is does not contain zero, that is evident from the data that mu1 is less than mu2. Mu1 less than mu2, that's why it's negative. Okay, hence we estimate that the non-consumer of high fiber breakfast, okay, consume on average between 1.83 and 56.59 more calorie for lunch. Okay, why it can become positive? If mu1 minus mu2, you got the negative. If we reverse mu2 minus mu1, we'll get positive lah. Positive, that's why, okay, mean the population 2 consume more, okay, consume more calories, because if we reverse mu2 minus mu1, the value will be positive between, okay, the interval 1.83 to 56.59. Okay, so we okay, recall back, okay, we just focus on the first case to find the confidence interval for difference between two means, okay, where, okay, the n are greater, both n are greater than 30. Okay, so with this, thank you for your attentions.